We are on Module 2. This is Anatomy and Physiology, Part 2 of the lecture on Module 2. Alrighty, so we are on page 2 of your notes, and we are talking about the type of epithelium. We're talking about stratified cuboidal epithelium, stratified transitional epithelium, and pseudo-stratified epithelium. We talked about it last time, but we kind of hustled through it, so I wanted to mention it one more time. I would recommend you be familiar with these drawings on page 32, make that 34 through 37, maybe even through 39. Just saying. I think you should be familiar with them. Might be fun to draw. Stratified cuboidal epithelium is on page 37. Nice little drawing of it there. These are uncommon, but they offer protection and tend to be used for secretion. Stratified cuboidal cells are in salivary glands which secrete saliva. Also, stratified columnar are found in the larynx. So, interesting little deal there in terms of these stratified squamous epithelial cells. Stratified transitional epithelium on page 38. If you'll take a look at those. They offer good protection. They are multi-layered, of course, and it stretches to form fewer cell layers. Think of the urinary bladder in terms of the stretching that is required there of the bladder. Pseudo-stratified epithelium. I've always thought those were interesting in the sense that they look like they are stratified, but they are not. And what happens is you have cells which contact the basement membrane, but some of them do not reach the free surface, and so all of the cells touch the basement membrane, but some are shorter than others and do not touch the free surface. They possess goblet cells, often possess cilia. They are in the large airways of the lungs. Mucus traps particles in the air, and the cilia moves the particles out of the airway in the form of sputum. You cough that stuff up, you know. But it's a beautiful cleaning function that God has given us to clean out our lungs. So that's where we were last time, and let's move on to glandular epithelium. I'm at the bottom of page 2 on your notes. That's epithelial tissue found in the glands. It consists of exocrine glands and endocrine glands. Let's define those. Exocrine glands are those that secrete substances outward. If you would, turn over to, page 42. I didn't refer you in terms of where we're at. Page 42, more pretty little pictures. We love the pretty little pictures. So exocrine glands secrete substances outward to the surface through a duct, and they have many shapes and sizes, but with the same basic structure. And so you see all kinds of them there as depicted. There are the secretory portion of these things. They contain cells that do the secreting and contain a duct through which the chemicals travel to a surface, either inside or outside of the body. Stomach glands, of course, secrete on the inside, onto the surface of the stomach. Mammary glands secrete onto the surface of the skin. So that is that secretory portion in terms of these glands. I'm moving over to page 3, and actually I was reading from page 4, so I don't want to do that. Let's see here, and of course I am missing page 3, so probably would be good to have it. go. That'll do. Alrighty. So in terms of classifying exocrine glands, again, the word crine means to secrete chemicals. So there are the merocrine glands. These are depicted here on page 43. Marrow means a small part, and exocrine glands that secrete without losing their cellular material. They secrete via exocytosis. In other words, a secretory vesicle is released. No cellular material in the secretion. So the classic example of that is sweat glands. And you see that is depicted there in figure 2.8 on page 43. The merocrine gland is just secreting via exocytosis, and there it is depicted. The second type of gland is an apocrine gland. Apo means a part of, so you had a small part, now you have a part of. Exocrine glands that have cytoplasm in their secretion. Cells pinch off a portion of themselves, incidentally, never the nucleus, and you can see in terms of the middle drawing there, the apocrine glands, you see what they mean. You see some of the cells in the process of getting pinched off, and others have already made it. They're officially pinched. All right, and but it's never the nucleus in terms of part of that cell, and it puts the cellular material, the cytoplasm, in the secretion. And an example of an apocrine gland is mammary glands. All right, so in terms of some of the nutrition and some of the important stuff that you get in terms of breast milk, you also get the protection portion of it as well, so very important, obviously. Finally, holocrine glands is the last depiction there. Holo means whole, so you gotta figure that there's a lot of the cell in there, and as it turns out, exocrine glands whose secretion are made up of disintegrated cells. The entire cell gets secreted, ejected into the duct where they rupture, releasing their secretion. The cells are constantly replaced by mitosis. Examples of this are sebaceous glands that secrete oil that soften the skin. So I have got the softest skin that you've ever seen, ever touched. It's just so soft. Oh, that's just plush right there. If you could capture that oil that my skin produces, I think I could light the whole city of Madison, but unfortunately you can't. So some folks are like me. You have very active sebaceous glands, and that is a holocrine gland. Okay. Endocrine glands are ductless glands. Let's see. Nope, let's just stay where we're at. They secrete hormones, which are messenger chemicals. That's what we discussed a few weeks ago. Directly into the bloodstream. Has a cell packed on cell, but without ducts that endocrine glands possess. Capillaries run through these cells, bringing oxygen and nutrients to these cells and picking up the secretions. By exocytosis, they form vesicles. To summarize all this, epithelial tissue functions. You have tightly packed cells for protection, absorption, secretion, or diffusion. So that's what's key with regards to epithelial tissue. So pause there for a moment. Deep breath. Any questions about epithelial tissue? Well, let's move right along to connective tissue. That begins on page 45, but you got nothing interesting there. So turn over to page 46 and 47. Oh, that's good today. So connective tissue forms the body's infrastructure. Holds you together, all right? You'd fall apart if it wasn't for connective tissue. Binds together and supports tissues. It also insulates. Cells secrete a number of products outside of themselves. That's extracellular material that positions between cells, resulting in the cells being relatively far apart. And as you say, relatively. So let's define the extracellular matrix. It is defined for you on page 46. One thing you'll have to write down. As you see, you're getting less and less to have to do this. But the extracellular matrix is the chemical substances located between connective tissue cells. As it turns out, that stuff's important. The chemical substances located between the connective tissue cells, extracellular matrix. All right. There's something called ground substance. That is extracellular matrix chemical mixture containing proteins that the cells secrete, which attract water to make the ground substance gel-like. Some cells secrete proteins that form fibers, protein threads, such as collagen. A third of bone tissue is collagen, all right? That's a protein that holds connective tissue together. The deep part of the skin, the part that makes it firm and not wrinkly, is made up of collagen, all right? You see advertisements that's going to solve the wrinkle problem in your life because it contains collagen. Well, in terms of adding that into the skin, that's not necessarily going to do it, certainly not for very long. Let's classify the connective tissue. It's based on the extracellular matrix that I just defined for you and reminded you that it's kind of important. So it is hard and flexible and stretchy. So there is connective tissue proper, there is cartilage, bone, and the blood. Yes, it's hard to think of blood having connective tissue, but it does. It's quite a bit, as a matter of fact. So let's look at connective tissue proper. That discussion begins on page 46. You see loose connective tissue and dense, irregular connective tissue in terms of the drawings. We're going to look at those. So it is divided up into 4 types: the loose connective tissue, adipose tissue, dense, irregular connective tissue, and dense, regular connective tissue. So loose connective tissue has gel-like ground substance to it. Protein, fluid, and collagen fibers that make it very elastic. Its function is light-duty binding. In other words, the entire extracellular matrix comes from the connective tissue proper cells, which are called fibroblasts. Spindle-shaped cells that form connective tissue proper is a fibrocyte. And that is a term for a fibroblast after it is surrounded by the matrix. So look at your drawings here. You've got some indications of these things. You see the elastic fibers. You see to the right there of the pink, little pretty pink stuff. I'm looking at page 46, incidentally. Loose connective tissue. You see the pretty pink stuff is, hello there, how are you today?
Good. Got class times mixed up. Sorry.
What was that?
I got class times mixed up on right there. So.
Oh man, I'm sorry. And what is your name again?
Aiden.
Gotcha, Aiden. I'm glad you're here. All right. All right. That's everybody. We're about to finish up page 3 of your notes, Aiden. But notice what we were talking about. The fibroblasts, the ground substance magnified. I've got to have this today. And the elastic fibers that surround it, and again, depictions of what we're talking about in terms of this. So that is loose connective tissue. Turn over to page 4 of your notes. Loose connective tissue is sometimes called hypodermis, though it is part of the skin. So that is the epidermis and the dermis. The second type is dense, irregular connective tissue. You see that displayed on page 47, figure 2.10. It is part of the skin, the dermis. It is dense. It contrasts the loose connective tissue by the significantly greater number of collagen fibers present. The irregular refers to all directions orientation of those collagen fibers, and it functions by strength in all directions. And so you can pull on your skin and stretch it all over the place. And as you get older, you got lots of extra skin to do that. So you pull this thing and it goes every which way. And there's strength to that. It doesn't allow the skin to tear easily. Also, it is in capsules around organs. So look at the comparison in terms of this stuff. Notice then in terms of the number of elastic fibers and collagen fibers that are in this dense, irregular connective tissue as compared to the loose connective tissue. And also notice in terms of the irregularity how they're going in all of those different directions. That's what allows for the stretching in all different directions. So turn the page and contrast that to dense, regular connective tissue. You know, do the back and forth deal. Dun, 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 dun. And notice those collagen fibers are all headed in one direction on dense, regular connective tissues. It is similar to dense, irregular connective tissue, only the collagen fibers are regular. In other words, they're lined up there in the same direction. There are no elastic protein fibers, and the function here is rope-like or tensile strength. Think of the tendons that hold muscle to bone, as well as ligaments that attach bone to bone. So it gives tensile strength to those things. You can pull on a rope and it doesn't break, right? No, hopefully, if it's a good strong rope. Had a guy cut down a tree yesterday. Didn't look to be that big a rope, but one guy on the rope and the other guy in the tree making the cuts, and the guy on the rope pulled the tree in the direction it needed to go, which meant not on top of my house. So the rope worked. Rope has tensile strength to it. And then finally, the last type of connective tissue is adipose tissue. That adipose means fatty, is similar to and has all of the ingredients of loose connective tissue plus fat cells. And so you see the difference there. Again, do the back and forth between loose connective and adipose, and you see they're sort of similar with the addition of those adipose cells. So they have a couple of functions. They store energy, they insulate, they hold in place. So the kidneys, the mammary glands are braced and held in place by adipose tissue. It insulates the mammary glands, the body under the skin. So that's why in the wintertime, I'm always as toasty as I can be. I'm so well insulated. So, sad. Connective tissue heals very slowly. Anybody here torn an ACL, torn a ligament, your Achilles tendon by any chance? What did you tear?
I tore a tendon in my knee.
I didn't hear that.
I tore a tendon just or they were kind of like ligament or anything like that.
How long did it take you to heal? How long before you can?
Months.
What's that?
A couple months.
I still can't hear you.
A few months.
Yeah, yeah. Good long healing time. Daughter tore an ACL playing soccer. It was 3-4 months, something like that. Yes, sir.
I ripped up my wrist real bad.
Really?
I'm pretty sure that's what it is. We never got an X-ray, so it's possible they were broken, but
Wow.
I mean, I couldn't move them. They're still healing. It was
Better now.
6 months ago.
Do you have to have surgery?
No.
Oh, wow.
It was a good 6 months ago, but they're still healing.
Wow, wow. That's tough stuff. Boy, oh boy, be careful in the future too, in terms of future pain. But anyway, you notice how long it takes those things to heal. So, and the problem is, in terms of their reproduction, their mitosis, their role of secreting extracellular material essentially their function keeps them from dividing and healing quickly, especially compared to epithelial tissue. Again, with regards to various aspects of epithelial tissue, you have fast healing, but the connective tissue you do not. So, is there questions about connective tissue? We're actually getting along. Where are we? We're not too bad. This is good. Let's talk about cartilage. All right, it exists, and if you would turn over to page 50. So. It's a rare day, but it's a 2 day. I'm gonna break into the second. All right. Everything is better now. Cartilage. See the pretty pictures in there, and interesting pictures as well. Exists in 3 types: hyaline cartilage, elastic cartilage, and fiber cartilage, all of which have chondrocytes. Chondro means cartilage. Cells that produce extracellular material. They, in terms of mature cartilage cells, it's firmer than connective tissue proper because cartilage matrix is firm. Cartilage cells cannot live there and live instead in some things called lacunas, which we're going to discuss in just a little bit. Those are small, hollowed out spaces. Extracellular matrix of cartilage is different from connective tissue proper in that it has no blood supply. It's avascular. Oxygen and nutrients have to diffuse through the matrix. So the matrix in this instance must be relatively thin. Like connective tissue proper, the cartilage matrix always has collagen. And so notice there in terms of the matrix magnified in both figures 214 and 213, fiber cartilage and the hyaline. But notice there in terms of the collagen fibers. And again, we're going to have something similar in terms of irregularity and regularity. So, hyaline cartilage is the collagen is hard to see and doesn't stain. It gives hyaline cartilage its hard, plastic-like resiliency. Think of the bridge of your nose, the costal cartilage of the ribs, the caps on bones and joints. You've seen hyaline cartilage on the caps of chicken legs, and some of you, sadly, either my wife has had a deviated septum for as long as I've known her, which is almost 40 years now. She had it since she was a little one. At some point in time, she must have broken that piece of cartilage because it is significantly distorted. You can't see it on her face, but in terms of her ability to breathe through her nose, one nostril is severely occluded in the sense that there's hardly any space there. And so, again, that's made of that hyaline cartilage. Fiber cartilage contains much fiber. It has parallel collagen fibers. Its function is tough and tough binding and resilient support. It's found between the joints of each vertebra. The joints are in a tough binding but are resilient enough to cushion the spinal column for walking and jumping. When you have a slipped disc, anybody here yet have back problems? I sure hope not at your age. If you play sports the wrong way, you can develop back problems at any point in time. But this is a relatively common one where sadly you either lose or it is moved, but a slipped disc has to do with that, and then closing the space, or at least part of the space between it and the spinal cord, which is ultimately why you have pain, but in any respect. Elastic cartilage. Let's see, that should be depicted on the next page, and it is. There is an odd-looking ear, but that's what that is. Elastic cartilage contains collagen, but not a lot. It rather contains elastic fibers, making them stretchy. This is soft plastic, like the outer ear or the very tip of the nose. So that cartilage is much more movable than the hyaline cartilage at the bridge of the nose. Turn to page 5. All right, in terms of bone tissue, we are all the way to the bottom. You know, I should ask, was there any questions with respect to cartilage? You ask so many questions. How could I forget to ask you if you had any questions? All right, calm down, one at a time, one at a time. All right, we're moving though. This is actually good because we can get done this way. Bone tissue is known as osseous tissue. Cells are far from each other. They secrete ground substance, fibers, collagen fibers, and fluid. Ground substance becomes hard through a process called calcification. So guess what? We're going to spend significant time on bone tissue, and the next one, blood tissue, known as vascular tissue, has cells, red and white blood cells, ground substance, that's the proteins in the blood, fluid, that's the blood plasma, and even fibers in certain circumstances, especially with clotting. So we're going to spend a lot of time on both of those in the future. So guess what? You've discovered that really most of this module is on the things that we have already discussed, the epithelial tissue and the cartilage, and that's about it. So yes, questions about those two? As I say, we're sort of doing is introducing them as connective tissue, but we're not going to go into them because we'll spend a lot of time on them. They each get their own module. All right, membranes at the top of page 53. Boy, we're almost done. Almost. Y'all actually are going to get to go home today after all. So, membranes. Are made up of epithelial tissue and connective tissue. The epidermis is stratified squamous epithelial tissue. The dermis is dense, irregular connective tissue. Then there are loose connective tissue. Three membrane categories: mucous membranes, synovial membranes, and serous membranes. So they are defined on these pages. Not any pretty pictures though, sad to say. So mucous membranes are in the lining of the mouth, the stomach lining, the digestive tract, the respiratory tract lining, the urine and reproductive tract linings. Lines the tubes that open to the outside of the body for protection. So that's what mucous membranes do. Serous membranes form thin, double layers around organs and secrete small amounts of lubricating fluid into spaces between the layers, reducing friction between the organs. The synovial membranes are found in the movable joints and are also used for lubricating. Bones covered in hyaline cartilage that meet in a joint are lubricated by synovial fluid secreted by synovial membranes, which form a little sac around the sides of the joints. So my brother has slowly become the bionic man. Anybody know what that is from? I have dated myself once again. So that was a TV show in the 70s. And so what happens is this guy is in a terrible accident, and so they replace him with mechanical parts. And so he's able to run fast and jump high. He's sort of a full Iron Man type thing without the suit. All right. But anyway, the point of my story is he had to have 2 knees replaced and a hip. And the way it works out is this synovial fluid begins to go away, sadly, and so the lubrication goes away, and so you're rubbing cartilage on cartilage, which then, anybody familiar with friction, you know what that does to something. That's why you put oil in an automobile. It reduces friction, which causes heat, and then causes the destruction of those protective cartilaginous areas, and then ultimately you've got bone on bone, and so that becomes very painful. And so in terms of sometimes the way we age, he had a medical condition that also contributed to this sort of thing. But the bottom line to it is that that's part of what we're talking about here in terms of these membranes that allow for this lubrication. So tissue repair, interesting stuff. This sort of thing interests me a lot. Maybe it will to you too. There are 2 types of tissue repair. I'm on the bottom almost of page 5. There are stromal cells and parenchymal cells. All right, stromal cells are cells that provide structure or support for parenchymal cells. If these cells are restored, it's better than nothing, but the organ does not function well, and I'll explain that in a moment. Parenchymal cells are cells that provide the actual function of the tissue. If these cells are restored, tissue function also returns to that organ or to whatever it might be. The determining factors for whether or not parenchymal cells or stromal cells are restored. Cells in different tissues have different abilities to regenerate. There's 3 categories. There's labial cells that undergo mitosis regularly and quickly. That's epithelial tissue of the mouth. It regenerates fairly quickly. So anybody here bite their cheek accidentally? So yeah, that's awful. I mean, I've been doing this in my sleep lately. There's one section of my mouth that I've decided must taste good, because I'll bite that and man, that hurts. But fortunately, because of the cells, because of the labial cells, you know, it hurts for a little while, but it goes away fairly quick because the cells that I've destroyed by chomping on it are restored fairly quickly. Stable cells are cells that do not undergo regular mitosis, but they can. Think about bone cells. They don't reproduce unless a bone is broken. The blood supply is cut off to the affected area. Then bone cells die, but neighboring cells then undergo mitosis. When we get to the bone portion of our study, we'll find out exactly how that works. But so, anybody here broken a bone? So we got broken bones all over the place. So did they put you in a cast? Did they set you? Is that right? Anybody here get a pin? Anybody have a bone pinned because you had such a severe break? So what they do, if you've heard of pinning bones, they put a steel rod through the middle of your bone, which again we're going to discuss the anatomy of that. It's to hold the two bones that are broken together in a way that's straight, number one, but especially to get those bones together closely enough where the cells that are undergoing mitosis will connect and allow your bone to heal. Now that takes time. A lot of times you can get back on a bone, you can get off crutches, you can start to walk or whatever it might be, you can lose the cast off your arm in about 6 to 8 weeks. But they tell you don't stress it because it takes about a year for that thing to really heal. So you got to be careful. I mean, you've got football players and baseball players that are right back out there after 8 weeks, but you got to be careful because that's still healing. But they have to be aligned in order to get there. And again, that takes time. And that then is the product, as we said, of stable cells. But then there are permanent cells. I'm on the last page of your notes. Cells that cannot undergo mitosis. Those are nerve cells, specifically nerve cells of the spinal cord, and muscle cells, certain muscle cells, that is of the heart, that do not replace parenchymal cells, but they replace stromal cells. So we've already introduced this. Oh, real quick, better circulation brings white blood cells, removes waste. Better nutrition, proteins and vitamins are critical to repair, and age is a factor in tissue repair. So eating a good balanced diet is a good way to heal tissue that gets damaged or destroyed. A better circulation in terms of having regular exercise and having a cardiovascular system that's not clogged up. But we discussed briefly introduced the idea of parenchymal cells and stromal cells. So when you have a heart attack, and I pray you never have a heart attack, but when somebody has a heart attack, what happens is a vessel to the heart muscle is cut off for some reason, a blockage in one of the vessels. And so the part of the heart that was cut off, that part of the heart muscle dies. That's right, it's dead. And so what has to happen is those cells have to be replaced. And they are. But the problem is the types of cells that replace them are stromal cells, not parenchymal cells. That's what heart muscle does. It replaces with cells that are not squeezing type cells. They're not efficient at squeezing. They're there, the repair is made, but the heart is not nearly as capable as it was. And so sometimes, as a result of that, the heart will expand, it will get larger, and that actually doesn't make it better, it makes it worse, it makes it less efficient. So that's the key in terms of heart attacks. You can't replace those cells. And so, the idea is to keep those vessels clean and clear so obviously that don't happen. All right, we made it. Is there questions or anything at all, comments about this stuff?